Hello students, today we will discuss a very important topic, function with permutation combination. Means when both concepts comes together, it makes question complicated, but if you have concept, then you can solve it very easily. I am going to start with very simple way. Suppose a function is defined from set A to set B, and the number of elements in set A is equal to m and number of elements in set B is equal to m. Then if someone is asking how many functions are possible from set A to set B, suppose I am writing x1, x2, x3 up to xm, and here y1, y2, y3 up to yn. From A to B function is defined. For every element of A, we have n choices, and there are m elements in set A. We can apply fundamental principle of counting, the product rule, and by product rule number of functions will be what we can say, it will be n into n m times, and it will be n to the power m. Now someone is saying that how many one functions are possible. In this case we can consider a rectangle, like suppose that this is the rectangle, or partition the rectangle in how many parts? Partition the rectangle into m parts. Partition the rectangle into m parts. For first place we have n choices. For second place we have n minus 1 choices. In same way we can write n minus m minus 1 for last choice, for last rectangle, and again we apply fundamental principle of product rule, and it will be number of one functions. Number of one functions will be n into n minus 1 into n minus 2 multiplied up to n minus m minus 1, and this expression can be written as npm or n factorial by n minus m factorial. This is the formula for number of onto functions from set A to set B. Let us see next concept. In this concept we have to learn composite function. F of fx is composite function of f, and it is equal to fx. Just see by simple example. If we are taking a is equal to 1 2 and function is defined from a to a. Observe what is going on. If we are writing like 1 2 1 2 1 2 and saying that this function only one element is in range, means fx range of fx has only one element, and this can be taken like selection of one element from two elements. Just observe, one is selected and one is mapped to 1 because there is only one element in range. There is, so 1 is, just consider it. Then we will write f1 is equal to 1 and f of f1 it will be f1. There is no any other chance for 2, and here f2 is equal to 1 and f of f2 is equal to f1 and f1 is equal to 1. F of 1 is equal to 1 and it can be also taken as f2. Here is f2. Next, so if only one element is in range, number of functions will be 2c1 into 1. And if there are two elements, so 1 2 1 2 1 2. One possibility is 1 is mapped to 1 and 2 is mapped to 2. This is the one possibility. Second possibility will be 1 2 1 2 1 2. 1 is mapped to 2 and 2 is mapped to 1. Here 2 is mapped to 1 and 1 is mapped to 2. Correct? Means again we have two conditions. One is like this and second is like this. In broader sense, how we can solve a question which is really some complicated. Question is, find number of functions from A to A where A is equal to 1 2 3 4 and f of fx is equal to fx. This is the question. How we can solve such type of question? For this we will approach that range has only one element, range has only two elements, range has only three elements, range has only four elements. Like this we can solve the question. Just observe, if range has single element, if range has single element, then that element can be selected like this. In 4C1 the single element will be selected and rest elements will map with that single element. Means let us see 1 2 3 4 1 2 3 4 1 2 3 4. If selected element is 1 and we are writing f1 is equal to 1, f1 is equal to 1, then this will be mapped to 1, this will be mapped to 1 and this will be mapped to 1. For only one element, this will be the system. It is a one ways and number of selection is 4C one ways. If range has two elements, If range has two elements, then firstly select that two elements, and surely two elements will, out of four elements, two elements will map to directly themselves. Suppose we are taking 4C2. Two elements are, F1 is mapped to 1 is mapped to 1 and 2 is mapped to, these are mapped directly. Now 3 and 4 has each have two choices. 3 can be mapped to 1, 3 can be mapped to 2. In same ways, 4 can be mapped to 1 or 4 can map to 2. So we can write 2 into 2. If range has 3 elements, then we firstly select the 3 elements out of 4 elements, and remaining 1 element have 3 choices. So we can write here 3 choices. It will be 4 into 3, that is 12. Here it will be 6 into 4, it will be 24. And here 4C1, it will be 4. And if range has 4 elements, then select them as 4C4, it is 1. Total number of functions will be, this is 4, this is 24, this is 12, and this is 1. Means number of functions will be 41. Such type of function will be 41. Let us see the next type of question, which is also very interesting. I assure you that in very easy way I will explain complicated concepts. Next concept is, if someone is saying that how many strictly increasing function or how many strictly decreasing function both have same type of concept, and just see if we are taking y1, y2, y3, yr are elements, and someone is saying that arrange this in ascending order, then in ascending order there is only one possibility. Means if we have to make functions for strictly increasing or for strictly decreasing, they must be 1, 1. First condition is they must be 1, 1. If A has m elements and B has n elements, and one required condition is n should be greater or equal to n, then number of strictly decreasing or strictly increasing functions both should be equal to NCM. Means number of selection of n elements out of n elements from set B. This will give the number of strictly decreasing function, or the number of, or clarity, write it, number of strictly increasing function will be equal to number of strictly decreasing function. Next is number of non-increasing that will be equal to number of non-decreasing. There should be no confusion in strictly and non-increasing, non-decreasing. Both are different concepts. Concept for non-increasing or for non-decreasing, you can learn like, suppose I am giving one explanation. Here is x1, x2, x3 and xm, and here y1, y2, y3, and this is y. Y1 can be connected to R1 element, just let it. Y1 connected to R1 elements and Y2 connected to R2 elements of set A. In same way, Yn connected to Rn elements. Just think, R1 can be 0, R2 can be 0, Rn can be 0, R1 can be from 1 to M. R1 can be, all the elements can be connected to Y1. Means sum must be equal to M. And what we have to do? We have to find non-negative integer solution of this linear equation. And that is equal to m plus n minus 1c m. This is the nice formula for non-increasing or non-decreasing number of functions. By taking this, in IIT Advanced, questions are asking on these concepts. Just I am giving some more illustrations by example. See one example. F is defined from A to A and A is equal to 1, 2, 3, 4. This is definition function. This is how function is defined from A to A. Question is, if A is equal to number of functions from A to A, B is equal to number of functions, number of 1 functions from A to B, and C is equal to number of strictly increasing functions, and D is equal to number of non-decreasing functions, then A plus B plus C plus D is equal to what? This is the fundamental question. If any student know the fundamental, can solve it very easily. So just recall, A is 4 to the power 4. Number of functions is n to the power m. Number of 1 function will be 4p4 npm, that is 4 factorial, and C is a strictly increasing function, that is 4c 4. Number of strictly functions will be 4C 4. And number of non-decreasing functions, then it will be 4 plus 4 minus 1C 4. Means this is 256 and this is 24 and this is 1 and this is 7C 4. Now it is very easy to calculate it. You can calculate it. We are discussing very important concepts. Let us see. F of fx is equal to x. Such type of number of functions, we have to find such type of number of functions. Just see a simple example that f is from a to a and a is equal to 1 to like this. If fx is equal to x is for only one element. If this condition hold for only one element, let it be f1 is equal to 1. f1, then f of f1 will be f1 is equal to 1. Then f2 will not equal to 2. Then what will be? f2 will be equal to 1 and this contradicts. Means if there are two elements, then fx is equal to x for only one element is not possible. Next, if two elements are there, then we can write f1 is equal to 1 and f2 is equal to 2. Then f of 1 is equal to f of, then f of f1 is equal to f1 and that is 1 and f of f2 is equal to f2. It is possible. It is possible. Next, we can write f of 1 is equal to 2 and f2 is equal to 1. Means f of 2, f of f1 is equal to f2 and this is equal to 1 and f of 2, f of f2 is equal to f1 and this is equal to, this is satisfied. Means there are, these conditions are satisfied but this condition is not satisfied. What we are observing, either A is mapped to A or A is mapped to B and B is mapped to A. We have learned from these conditions. Let us see a question. Which type of question can be asked? If f is defined from 1, 2, 3, 4, 5 to 1, 2, 3, 4, 5 and f of fx is equal to x, then number of such f is what? Such type of concept is most important. They can be asked in coming examination like ISI, like IIT Advanced. So let us see how we can solve such type of question. How we can start? We can start that always we have to keep the elements of set A in pairs and some selections can be taken. If A to A, what we have to consider? A to A to B and B to A. This part If A to A part is taken, for this we have 5C1. By 5C1 we can select one of the element of this function. There are remaining 4 elements, and the 4 elements can be taken in pairs, and they can be taken in pairs in how many ways? Factorial 4 by 2 factorial, 2 factorial and 2 factorial. If one element is selected, then remaining pair AB can be selected in 4 factorial by 2 factorial, 2 factorial, 2 factorial. Means we have to divide 4 elements in 2 equal groups containing 2 elements in each group. That is factorial 4 by factorial 2 factorial 2 factorial. If 2 elements will be taken, pairing is not possible. So we will not take 2 elements, we will take 3 elements. 3 elements from A to A. And remaining 2 elements can be arranged, can make a group. 2 elements can make a group in factorial 2 by factorial 2 in single. Rest, if we take five elements, there will be each element will map in A to A ways in 5C5, that is in one way. Total value will be 5 into this is 3 and this is 5 into 5C2, that is 10, and this is equal to, it is equal to 26 way, means number of such type of functions is 26. Okay, let us see one of most interesting question. Overall concept what we have learned. This is one of the most conceptual question on which 2 questions are asked in previous IIT Advanced. So let us try to solve this conceptual question. First is multi-correct question is this: number of functions f is less than 512. It is correct or not? Here observe the data. Number of elements in domain is infinite and number of elements in codomain is 4. Number of functions is less than 512. The concept that number of functions is n to the power n, this is infinite, and this is saying that it is less than 512. Means this option is not correct. Okay. Number of continuous functions is less than 256. This again, see the number of continuous function. How we can observe continuity in the interval? Continuity in the interval can be observed like this. This is for open interval, this is for open interval, this is for open interval. How many intervals are there? 1, 2, 3. These values can be rearranged in how many ways? In 4p. In how many ways? Here are three conditions, 4p, 3. How these can be arranged? In 4p, 3. So, the number of continuous functions will be 4p3 and it will be 4 into 3 into 2, and that is 12 into 2, 24. And here is number of continuous function is less than 256. It is correct. The number of continuous function and the number of differentiable function is 256. This is obviously not correct. And the number of non-decreasing functions is greater than 512. Non-decreasing will be what? Here the value of m is infinite. So, if we are saying that m plus n minus 1 cm, obviously it will be infinite and is greater than 512, it is correct. Means this is the correct choice. B and D are correct choice. A and C are wrong choice. You can visualize and analyze this question. Again, we will come with good concepts and good questions in next class.